Howdy everyone, I'm here with the Texas A&M Chemistry Roadshow, and today we are going to do what we love to do and blow things up with the water bomb experiment. Now, everyone blows things up, and usually, almost all the time, we blow things up hot. Today we're going to do something up, blow something up cold. Exactly how cold we're going to blow it up is liquid nitrogen cold, which is 321 degrees. So let me go and get that ready first. Nice steam at least, and it'll keep me cool while I do this experiment. But that's only the first part. Now, here's my bomb. And as a safety demo, should I hit it with a wrench? Unless you don't like me for some reason, the answer is no. But I know this bomb, I know exactly what's in it, so I am going to do it because it's perfectly safe. Now, I'm going to put this in, and I'm going to step back. And actually, we're going to play a guessing game, because I know what's in this. It's going to make it blow up. And you probably do too if you think about it hard enough, but it takes a bit of thought. Now, put that in and back out. Now, if anyone is watching this from Texas, where Texas A&M is, it's hot. And generally, if we're drinking things, we want it to be hot too. Or not hot, because we want it to get cold. So, we can either put things in the fridge to get it cold, or if we get to, we can put it in the freezer. And I'm sure lots of you have done that. And if you have, you've let it in there too long. And what happens when you leave a drink in for too long, let's say sugared iced tea, you leave it in too long, you'll get a nice, lovely mess, and it'll basically blow up. Not as fast and spectacular as this is going to be, but it's going to do the same thing. So then, we're going to say, well, what's the main ingredient of that? And you could say sugar or tea, but then I'll ask a second question, what's the main ingredient of everything we drink? Which is kind of a trick question, and it's water. H2O. It's everywhere, it's inside us, we're most of it. Everything has it in. And you're probably already ahead of me on the logic here, but I want to walk through it. Is from that example with putting your drink in the freezer, what happens when ice freezes, when it gets down below 0 degrees centigrade, which this is negative 31 at least. Or I think I got the number wrong, but it's down. So it expands, and when it expands, it puts pressure on the things around it, which is a tendency to pop them open. Now here, we just have a cast iron ingot made by Senko Physics. It's called a flask form ice bomb. And currently what's happening is the ice is getting colder, and it's expanding. The ice is pushing out, and the iron is doing the only thing it can. They're staying there and pushing back in. The ice is pushing out, and the iron is pushing back in, and this thing is taking just a tad long. But in a few seconds, we're going to hopefully get a lovely explosion, which is cold and not hot. So we're just going to wait for that to go. That was amazing timing.